Okay, so now we have this density, density IO. But now what do we need to do? We need to sort it, right? Well, I sort it, so we need to do sorting, right? So this is my computer sort, right? And it's like simply sort values, right? Sort values for everyone. Saying the series must sort values for everyone. Okay, we can do series sort values because this is a series. Density is a series, right? Type density. It's a series. Waste memory short values. So what I can do is density and then density dot sort values. Sort values. See. So density of sort values and this is the value sort. So ascending order. By default ascending. So we want to rank, let's see, highest to lowest. Right? Highest to lowest. And you see I'm giving ascending order. So ascending is equal to false correlation. Different so now and then I do in place, right? So once I do that, let's see, density sort one. Okay? So let's density. Okay. So when you see keyword DC, right? So from the body, let's get the full thing. Density full. Okay? So fully means density like heading density head I can cross but you see some of the highest so 2010 man highest density kun state right? District of Columbia, right? District of Columbia. This was New Jersey, Rhode Island, right? Connecticut, Massachusetts, and so on, right? So you say population density, the ranking, right? This is what we wanted to do, right? 2010, it's a 2010 concept, right? So it's right? New York, although New York is a very big state. It's a state, city, state, state, city area. New York is so dense, very dense in terms of city. So New York City, New York State, okay? New York, New York City, New York City, NYC, city. Anyway, so this thing we can look at the tail, right? Tail areas, tail last also. So yeah, Utah. I've lived here, right? I've lived in Utah. I mean, I lived the density very part deserts, right? And deserts. So yeah, it's understandable. Nevada, yeah, it does make sense, right? Because I've lived here as well. Wyoming, Wyoming as a really एकदम sparse, very new person, and you have wizards, okay, wizards. So Alaska, of course. So I mean, your data does make sense. Does make sense. Okay. So what we did was we took these real world data sets and real world data sets or data, we we set out data science. You start with a question. Right? What do I want to do? Right? What do you want to do? What do you want to find out? What do you want to analyze? Right? So that you always start with that research questions. Data science question about starting. Right? So our question was, or our objective was to find the density or rank the states by their density, population density of 2010, 2010. So and then yeah, we were up to date, and then as you saw, a lot of time Kimagoy. I mean, you analysis actual analysis में very time लाया था
लागेन
धेरै टाइम केमा गयो डेटा क्लिनिङ डेटा प्रिपरेसन हैन डेटालाई प्रपर फर्मेटमा ल्याउने है त्यसमा चाहिँ सो सो द्याट्स भेरी इम्पोर्टेन्ट तपाईको वन्स त्यो हैन करेक्ट फर्मेट त्यो एउटा आफूले चाहिने जस्तो फर्मेटमा आइसकेपछि न एक्चुअल एनालिसिस चाहिँ धेरै टाइम लाग्छ है ओके सो सो एउटा कुरा चाहिँ वी स्टार्ट विथ द क्वेसन हैन अर्को कुरा चाहिँ देयर समथिङ कल्ड एक्सप्लोरेटरी डेटा एनालिसिस EDA भन्छ एक्सप्लोरेटरी डेटा एनालिसिसमा यु एक्सप्लोर द डेटा के रहेछ कसो रहेछ है यो हैन त्यसलाई चाहिँ अब त्यसको विभिन्न हिस्टोग्राम लिएर उसको समरी स्ट्याटस लिएर हैन सो यसको हैन त्यसको कोरिलेसन्सहरु के छ हैन सो अनि व्हाट क्यान वी डु विथ द्याट है एउटा डेटा आयो हैन so you're not sure what you want to do with that data right so this means you want to explore you need to explore first right and then you can decide your data right and then you formulate the question right you formulate the objective right so सुरुमा you do के हुन्छ नयाँ डेटा आएको छ भने चाहिँ के भन्नुहुन्छ you need to explore है त्यसलाई चाहिँ हामी exploratory data analysis EDA भन्छ है alright so and this is formulate your objective and then this was saying you start cleaning and everything and so now this Yusano example you see it gives you a sense of what data analysis and data science involves in the real world. Okay. All right. So now let's see. So okay, yeah, you can do say population data. Population when difference. So this population, right? Let's say we can do population.describe. I think we have used this before, right? I haven't. Very suggest. We got it. Describe.
Yes, sir.
Okay. So let's say it's called you summary statistics. These count 25, 40. Planet data set. Okay, go on back anyways. Okay. So it'll come anyway. Yeah. Okay. So very good. So any questions so far? Okay. All right. So let's get down to the next one then. Right. So aggregation and grouping. We can do efficient summarizations such as computing mean, sum, mean, median, etc., in which a single number gives insight into the nature of a large data set. Okay. Okay, so now Planus data. Let's use the Planus data set, which is available in Seaborn package. It gives you information on planets that astronomers have discovered around other stars. Okay, so let's see. Now another example. Okay, we have another example, which is very nice example here. Okay, so aggregation. Okay, this is like we need to do the analysis on we need to be familiar with some other concepts, okay? So aggregation and grouping, very important. Okay? So so what we can do is, let me just import Seaborn as SNS. SNS, you convention SNS. Seaborn as SNS. It takes a few minutes. And the load data set plan. So Planus data sets. Okay. Okay. And this while it's loading about this one. Excuse me. यसरी लोड डेटा सेट गरेँ हैन लोड डेटा सेट गरेर अनि त्यसको शेप हेर्यो भने तपाईको त्यसमा कतिवटा छ 1035 by 6 है 1035/6, like a head. So you can see that is method, number, orbital period, mass, distance here. Okay, so it's not you see it's पता लागेको planets है जस्तै कुन मेथडबाट पत्ता लगायो है कतिवटा पत्ता लगायो त्यसको orbital period नि अर्थ डेजमा हैन कति कति डेजको एक फुल अर्बिट गर्नलाई कति डेज लाग्छ है अर्थ डेजमा त्यसको मास डिस्टेन्स है अनि इयर कुन इयरमा पत्ता लाग्यो है सो यस खालको यो डेटा छ यस डेटा सेट है so let's okay so अब हाम्रो SNS dot load data set load data set and plan data set planets so in here like we need to put it in some your work data dot shape name 1035/6 so you can see that right method number कतिवटा यो method use गरेर there are different methods right यो method use गरेर यसमा एउटा पत्ता लगायो as I explained okay so and then okay so exoplanets details more than 1000 exoplanets discovered up right okay so simple okay before we can do analysis on planet data set right so we need to know some of these concepts right so that concept is aggregation what is aggregation okay, let's see so just like in NumPy arrays, pandas series, the aggregates return a single value. As aggregates, of course, they return a single value. So you can see that right here, say for Yoyoka, we're just creating this series, right? Let's copy this thing. Import NumPy. Import okay. This is our series. Okay. Over your series, I can do a bunch of these. Some sure. np dot np dot let me see. It's np dot mean I do sure. So yeah, it's pandas अब यसमा यसकै मेथड पनि छ सिरिजको आफ्नै मेथड छ series sir dot mean so yeah, it's the same thing right? You can either use NumPy but this is much easier right so you get the same so this thing you can do all kinds of other aggregation operations some right? Okay so likewise right median aggregation all those right you can do it okay okay method it's much easier to use the method okay okay so data frame you can do the same thing okay? Data frame so let's fix the oranges so fix that first thing. So let's see. You can see. Let's go back here. Okay, very good. DF. Hey, this is our DF. Hey, DF, sir. With your data frame, huh? I want to do this to some. Say DF dot mean. So what happens? Let's see. Right? So if I have this DF, I do df.mean, let's see, column को mean आयो, हैन यो column यसको mean र यसको mean, a को mean र b को mean, alright, so by default के आयो, so call यो column को mean आउँछ, mean rather aggregation, this sum j aggregation operation धेरै, so you get column wise just, by the way, it's taking snip for so I'll take it right away. Snip. So here we go. Okay, so yeah, so I can do that, those kind of operations. Let's see. With this one, yes, we can do just say row wise. Your row wise. Your row wise I will make it one. So if I do sum or sum, say your row wise I will is x is equal to 1. Now it gives me row wise, right? Row wise. So this is my df, understand? So यो दुईटा जोडेर यो आउँछ, हैन यो दुईटा जोडेर यो आउँछ and so on, right? So by default के हुन्छ x is 0. So we can do column, let's say you describe, just show me the describe, right? So df.describe, df.describe, so let's say के दिन्छ जस्तै यसको काउन्ट है a मा कतिवटा छ 5 वटा छ, b मा पनि 5 वटा छ, है 5 वटा छ है, अनि यसको mean कति हो है, a को mean यति छ, b को mean यति छ है, स्ट्यान्डर्ड डिभिएसन यसको यति छ, यसको मिनिमम कति छ है, 25 percentile कति छ, 50 percentile कति छ, 75 percentile कति छ, म्याक्स कति छ है, okay, alright, so तपाईहरुलाई percentile थाहा छ, what is percentile? So let me quickly explain what percentile is. So percentile is the 25 percentile mean, 25 percentile, 50 percentile, 75 percentile max, right? So let's try to make sense out of this, right? Okay. So I'm just going to show you quickly. Like statistics, you need to have statistics simple important if you want to do data science, because data science is basically based on statistics. So statistics important matter the matter. All is important. All right, so let's say it's my mean, okay, 25 percentile, 50 percentile, and this is max, so 75 percentile, 75 percentile max. Okay, this is your data set. This is our data. Your data, say. We say minimum, right? You say minimum. Say panel scores, it's listed. Panel is equal A. Right? It's equal A. And your A line, right? This is A. A one dimensional data. Right? A is this minimum, right? Minimum values, right? And there is something called minimum. It's A line, right? Minimum condition. When you see 0.12. 0.1%. That is 0.1%. Right? Minimum say 0.1%. This is 25% that is 0.13. 25%, 0.13. 0.13. You see 25 percentile. Okay. And this thing I have 50% 0.39. 39. Right? So maybe around here, right? 0.39, let's see. कति 50%. Okay, so 50%. Okay, and this we see 0.47 or 75. Maybe here, right? 75%, 0.75. Okay, and this is maxing 0.97. 0.97. 0.7. Okay. Sorry, not 7. This is max. Okay. So this is max. Okay. So rest is how many? Now this comes of given ID. What's the minimum value? Your A को minimum value कति छ 0.1, right? Maximum कति छ 0.97. अनि के छ भन्दाखेरि अब यसको 25% हैन 25% अब यो यसले हामीले यसलाई र्याङ्किङ यसलाई चाहिँ हामीले जुन यो A लाई हामीले सर्टिङ गर्यो भने चाहिँ यसको 25% सर्टिङ गर्दाखेरि 25% भ्यालुजहरु चाहिँ 0.13 भन्दा तल पर्छ यता है 0.1 25% चाहिँ है 25% सर्टिङ गर्दा 25% भ्यालुजहरु चाहिँ यो या भन्दा तल छ है ओके सो कहाँ 0.313 भन्दा सानो छ के है 25% भ्यालुजहरु चाहिँ यो सर्टिङ गरिसकेपछि है 25% भन्दा कम छ है त्यसै गरी 50% 50% भ्यालुजहरु चाहिँ 0.39 भन्दा सानो छ है ओके 75% भ्यालुजहरु चाहिँ 0.75 भन्दा सानो छ र यो त म्याक्स भइहाल्यो यो चाहिँ 100% म्याक्स भयो है सो यो यिनीहरुलाई चाहिँ पर्सेन्टाइल है दिज आर पर्सेन्टाइल्स है यिनीहरु चाहिँ पर्सेन्टाइल भनेपछि जस्तै 50% भनेपछि यो चाहिँ मिडियन है यो चाहिँ मिडियन है मिडियन भनेपछि किन भन्दाखेरि 50% of your 50% of the values are below this, right? Below this, 50% below this, and 50% above that. Notice the median one, right? 50th percentile, the median one. You know that 50% of the data, say, given the policy, 50% of the data, given the math, given the midpoint, right? Okay, so kind of makes sense. Okay, यसलाई अहिले हाम्रो प्लानस डेटा सेट हेर्दाखेरि अझै यसको अझै सेन्स आउँछ है ओके सो यो ओके यो पर्सेन्टाइलको कुरा बुझ्नु हैन कतिवटा जस्तै 50% जस्तै 50% अफ डेटा जस्तै यो हेरेर भन्नुस् कि हैन 75% अफ द डेटा कुन भ्यालु भन्दा कम छ
0.75
25% of the data kun value भन्दा कम छ
0.13
right okay very good so that's what it is right okay त्यसले चाहिँ it will give you very good insights है यो यसमा चाहिँ खासै है you have planned data set so then you will actually appreciate so far we got that यो भयो अब हामीले के गरौँ भन्दाखेरि अब planets describe है त है let's do describe planets describe planets describe है planets is not defined planets is data data that describe So over here, see, look at this. Count. Look at say isma null values are really ignored. So when we see number total kati wala cha 1035 wala cha 1030 wala 5 wala orbital period ma 992 wala baki nulls mass ma 530 matra cha baki sabai nulls here a non null values see right distance ma 808 year ma 1035 when we see yo tinta ma null रहेछ नि orbital period mass resistance within time nulls so if I do data dot is null dot is sum negative see method ma 0 null छैन नम्बरमा छैन orbital period मा 43 है 43 yeah, it makes यो र यो 43 जोड्यो भने यो स्टेटमा हैन मासमा 522 वटा नल छ डिस्टेन्समा 227 वटा नल छ है सो यो र यहाँ भएको जोड्यो भने 1000 है इयरमा छैन नल छैन है ओके सो इट अल मेक्स सेन्स है अब हेर्नुस् है यसमा लेट्स अब यतिले तपाईले धेरै अब इट गिभ्स यु a lot of insight into the data just with this just one line of code I describe right it gives you a lot of okay how the data is spread out how it's distributed so pretty much you have a good picture the data good picture so it's got mean me okay you the number is irrelevant yes, man. So say orbital period. Say so in orbital period, the mean period is 2002, 2002 days. Right? Standard deviation is pretty high. Right? Minimum minimum orbital period 0.09, right? Any 25% 5.44, 50% 39.97, 75%. 526 र max 73,000 भनेपछि धेरै यो डेटाको भनौँ न टप 25% चाहिँ हैन त्यो एकदमै 526 देखि 73,000 को बीचमा छ है भनेपछि धेरै 75% of the data 75% of the planetsहरुको जुन discovered planetsहरु छ 75% of the planetsहरुको orbital period कुन भन्दा कम छ days
526
भनेपछि we can हाम्रो pretty much analysis को लागि हामीले यो top 25% लाई त्यसलाई इग्नोर अथवा हैन त्यसलाई खासै महत्त्व दिनु जरुरी छैन हैन top 25% 526 भन्दा माथि भनेको जम्मा 25% top 25% है ओके सो त्यो 73,000 सम्म पुग्छ है which is a lot है so यो जुन टपमा छ त्यो चाहिँ के भन्छ एकदमै स्पार्स छ है ओके लेट्स लुक एट मास मासमा पनि हेरौँ है 513 वटा छ मीन कति छ 2 छ है स्ट्यान्डर्ड डिभिएसन 3 व्हिच इज गुड मिनिमम 0.03 देखि 25 त्यति बिग रेन्ज छैन यसमा र यसमा पनि हेर्नुस् न धेरै 75% अफ द डेटा कति छ 3 भन्दा कम छ है सो अब तपाईको डेटाको डिस्ट्रिब्युसन यही देखियो नि है यु क्यान सी द डेटाको डिस्ट्रिब्युसन हेर्नुस् त जस्तै यहाँ हेर्नुस् यसैमा हेर्नुस् है 5 जस्तै यहाँ 0.09 देखि 539 5.6 73,000 है डेटाको धेरै चाहिँ कति तलतिर झुम्बिएको छ यो डेटा है माथितिर खासै छैन एकदम स्पार्स है माथि स्पार्स है भनेपछि त्यो लोअर साइडतिर बढी झुम्बिएको छ है यु क्यान भिजुअलाइज द डिस्ट्रिब्युसन अफ द डेटा है जस्तै यसैमा हेर्नुस् है लेट मी clear this है अब यो डेटामा हेर्नुस् त सो यसैमा जस्तै कति छ 0.09 मिनिमम 0.09 छ है अनि त्यसपछि के छ 5.44 भनेपछि अब यो स्केलमा त तपाईँ एकदमै सानो यही नजिकै हुन्छ हैन यो अझै नट टु द स्केल है अब यो 25% 5.44 5.44 25% 39.97 39.97 है and त्यसपछि अर्को 526 maybe 526 ओके अनि यहाँ चाहिँ यो चाहिँ 73,000 is that right 730,000 was okay 730,000 अब यो स्केलमा त यो त एकै ठाउँमा यो अझै पनि यो धेरै टाढा छ यो अझै झुम्बिन्छ है सो अब यहाँ त अब 25% को डेटा यो त एकदमै स्पार्स एरिया भयो एकदमै स्पार्स एकदमै हैन स्पार्स मेन हाम्रो डेटा झुम्बिएको छ यो अझै त्यो कन्सन्ट्रेटेड हुन्छ यतिमा झुम्बिएको छ डेटा है ओके so it gives you a very nice picture of how the data is distributed right did you get a sense of that मैले भनेको कुरा बुझ्नु भयो
Yes, sir.
Basically of estimates. So all right, so now let's see Okay. So it's हामी के गर्न सक्छौँ भने हामीले यसको NA लाई ड्रप गरेर यसको there's a lot of NAs here हैन NA लाई हामी ड्रप गरौँ and then we can analyze dropping the NAs right so NA लाई drop so let's do that so data dot drop NA and this see that's data dot describe drop NA that is well it's like any drop letter describe so now अलिकति अब picture changes a bit यो गर्दै now so say यहाँ अब चाहिँ 17,000 so किनभने यसको कुनै पनि यसमा के हुन्छ भने now 498 मा झर्यो हेर्नुस् त कति थियो 1035 बाट 498 मा झर्यो है okay so 498 मा झर्यो so the data dot describe describe okay so it's the 1035 थियो नि 498 किनभने कुनै पनि रोमा एउटा मात्रै NA आयो भने त्यो गयो के त्यो गयो मिन्स त्यसले गर्दाखेरि अब NA लाई हटाइदियो भने एउटा मात्रै NA कुनै पनि रोमा हैन एउटा सेल मात्रै NA छ भने त्यो पुरै रो जान्छ त्यसले गर्दाखेरि we get 2/3 गयो या 1/3 मात्रै even half गयो half of the data is gone 1035 498 almost half the data see कतै न कतै null छ त्यो हैन so that means they are all gone okay so now त्यो गरेपछि now look at the picture change अब यो चाहिँ अब त्यति अहिलेको जस्तो त्यस्तो हाइली जुन स्क्युड मतलब एकदमै एकातिर मात्र झुकेको जस्तो डेटा छ यहाँ अझै छ है र अलिकति इभन अघिभन्दा अलि इभनली स्प्रेड आउट छ है अलिकति इभनली स्प्रेड आउट है त okay so now okay you can use this aggregation methods here so pandas aggregation either series or panda data frame I mean you can call all of these right sum okay so let's see how much time we got about 6 minutes so using your naya concept right split apply to line right so you're going to let time I'll just stop here today right as you think so tomorrow what's tomorrow Friday okay tomorrow we'll pick up right okay all right so to recommend attendance for this yeah so I'll the attendance here okay then right bye bye